So, as you might have seen in my older videos, I have this CNC laying around that basically had no use. It was built as a fun little project and it was not really used for anything else. So a few months ago I decided to add a 5-watt laser to it. You can also check out my older videos where I design a modular laser holder, and this is the same modular design that I want to use for this project. But basically one day I had an idea. What if I just took the same signal? Since I have the same modular design, I basically just could add any other tool I want. It sounds simple, but in reality it's a bit more complicated because this CNC is not the best for dealing with those kinds of torques and those kinds of forces because it has 8mm guide rods. It makes it extremely bendy. You have to keep in mind that when I started this project I only added the laser, and rigidity was not an issue back then, since the laser is only moving above the material and not pushing into it. And basically, as I said, I didn't want to redesign everything, so I just used the same signal. This means that you have the same 3 cables that the laser used: the 12 volt, the ground and the PWM signal. First thing was to buy the cheapest DC motor I could find. And after that I just had to design basically the same type of holder that the laser already had, but this time for a motor. But it was pretty simple because I still had the same project file, I just had to modify it a bit. After that I had to design some basic electronics. This made it possible to control the motor the same way I did the laser, because when you have a laser CNC, this means that you can use the PWM signal to set the intensity of the laser as you wish. But for a motor you need a bit of electronics, because my laser already came with its own electronics, I just had to plug it in. But in the case of a motor, which is also rated for 12 volts, you don't vary the input voltage, you vary the PWM in order to control the motor speed. So this is what I did, and I came up with this abomination. And please don't judge me too harshly, because this was my first electronics project and it actually worked. So yeah, what you need for a project like this is a MOSFET transistor that acts as a gate for the 12 volt power, only letting it through when the PWM signal is high, a pull down resistor and a flyback diode for when the motor stops. After I designed the whole mounting bracket, I 3D printed it using PETG. After that I just assembled everything together and made sure to add the same type of connector that I used for the laser. Basically it's a 3-pin automotive connector. Because this was a test project, I didn't want to bother with how I attached the electronics, especially since I didn't even test it before, so I just used super glue and hope for the best. The motor has 4 threaded mounting holes, so I screwed it to the holder. While this isn't the sturdiest mounting method, the CNC itself isn't rigid enough for this to be the first point of failure. And I also added a small chuck that will enable us to add end mills to the DC motor after we mount it to the CNC. And after I changed out the laser with our new tool, it was time to test it. And since the whole control board of the CNC runs on GRBL, I could use any software that is compatible with it to send G-code and see if it can start the spindle. And since I've been using LaserGRBL for my laser, I could use the same one, because the software doesn't care if you spin a spindle or power a laser, for it is just a PWM signal, so it's the same. After managing to start it, I wanted to try it on something, so the most logical step for me was to try to cut some wood with it. I had some balsa wood laying around and it seemed the perfect choice. But when it started to cut, I noticed some issues. First of all, since the bed of the CNC was never leveled relatively to the motion of the Z-axis, it was not uniform. This means that sometimes the spindle cuts more and sometimes it doesn't cut at all. And this is extremely bad, especially if you have a CNC that has 8mm guide rods just as mine. When I started this project, my naivety made me believe that this won't be such a big problem. But it caused more issues than I anticipated, and after a few trials and errors I had to look at what options I have. I thought about changing the rods to larger ones, but on further consideration it wouldn't be worth the money, especially since I'm not even using this machine. So for the moment at least I decided to leave it as is and move on to newer projects. If you enjoyed this project, you can check out the video's description where I linked some helpful resources. You can also leave your ideas in the comments on what improvements I could make. So until next time, stay crafty, comrades.